This is the 1.4 geometry quiz. Okay. Uh, this question was repeated from 1.3. Okay, so you can go watch it at 1.3. Okay. Question 2. Okay. The length of RS is how many centimeters? Okay, where this section is has to do with the tangent, the equation that has to do with the tangent and secants. Always know that the tangent squared equals whole times exterior, okay, and whole times exterior equals the other whole times exterior, okay. In this case here, we're working with a tangent QP, okay. So they want the length of RS, and you can see that RS is part of a secant. So the whole times exterior is going to be equal to the tangent squared. So 15 squared, because my tangent is the one for 15, 15 squared equals the whole thing, which is 9. Let's call this x. 9 plus x plus s. Sorry, plus 5, sorry, ys. Plus, 5, 6, as the 6. 9 plus x plus 6 times the exterior, which is 9. Okay, we can simplify this. 15 squared is 225. Okay, 9 plus 6 plus x is 15 plus x, and you have 9 outside. You're going to get 225 equals 9 times 15, which is 135. And then 9 times x is 9x. So you're going to get 9x equals 90. You're going to get x equals 10. So RS is 10. Okay. Then part B, they say the length of PS is radical k centimeters. Okay, we know now this is 10, right? They want PS. Let's call this x now. Okay, can we find it? Obviously, it's a right triangle. So you can use Pythagorean theorem, right? So x squared plus 15 squared equals 19 squared. Why 19 squared? Because the hypotenuse is 9 plus 10. Okay, you're going to get x squared equals 19 squared minus 15 squared. You're going to get x equals radical 19 squared minus 15 squared, which is root 136. So they want what's under the radical, which is 136. Okay, to the nearest integer, the length of MP. Okay, they want the length of this diameter. Okay, now we have this is 10, and we have this is radical 136. Don't you see, we kind of found this side and then we found this side, so they're kind of hinting us towards something, okay? In a circle, whenever you have this x and you're working with segments, this segment times this segment is equal to this segment times this segment. Okay, so let me rewrite this here. If they want MP, the whole thing, the whole yellow line, right? And I have this part here. I have this small part SP or PS. So I'm missing this MS part. Can I find it? Yes, I can. Okay, we know this is 10. We're going to do 10 times, let's call this X. 10 times 6, okay, always crossing each other. 10 times 6 would be equal to X times 136, root 136. X times root 136. And we know MP is equal, the whole diameter is equal to X plus root 136, right? Okay, and how do we find x? We just divide by root 136 here, so x will be 10 times 6, which is 60, divided by root 136. So over here, just so you know, to make things easier on the calculator, MP would be equal to, you can just put answer plus root 136. Okay, so let's go to the calculator over here. Okay, we said x is 60 divided by root 136. Okay, we're going to put answer plus root 136, and we're going to get 16.8. And they said, I think, to the nearest integer, so it's going to be 17. Round 16.8 to the nearest integer is going to be 17. Okay. Part D, to the nearest integer, the area of triangle QSP. Okay, QSP is here. We said root 136 here. Okay, and this is 10, but it doesn't really matter. How do you find the area of a triangle? It's BH over 2, right? So it's going to be base times height 15 times root 136 over 2. And if you put that on a calculator, 15 times root 136 divided by 2. No, wait. Root 136 divided by 2. Yeah, you're going to get 87.4. So to the nearest integer, it would be 87. Okay. Question 3. So for this question here, they said DEF are points on the circumference of the circle, and they mentioned, pay attention, they said these two lines are parallel. Okay, and they want you to find ODF. ODF would be this one over here. Okay, and since it's parallel, that means this yellow angle here is equal to its alternate interior angle, which is this one over here. Okay, and we know that this alternate interior angle here, the red one, the yellow one, is going to be half of this arc because it inscribes arc DE. And we know that this arc DE is 48 degrees because the central angle is 48 degrees. Okay, hence, this would be 24. And since this is equal to this would also be 24. Okay, then they say find the length of the major arc. Okay, the length of the arc, again, it's not required in this section, but it's theta over 360 times 2 pi r. Okay, and the angle for this arc, they said major arc. So to find the major arc, you do 360 minus the minor arc, and our minor arc is 48 degrees, as we did in part A. So it's going to be 312. Okay, so our theta is 312, and they said our radius is 11, so 312 over 360 times 2 times pi times 11. Okay, they said the radius is 11. If you put this in a calculator, okay, 312 divided by 360 times 2 times 11. Why am I not including pi? Because they want our answer in terms of pi. Okay, so you're going to get 19.0666 or whatever. Okay, so it's going to be approximately 19. Question 4, what's the value of x? For this one, it's very easy. Always remember, in a circle, like we did in question 2, this times this equals this times this. So 9x equals 36, so x is 4. Okay. Question 5. Here, always remember tangent squared equals whole times exterior. Okay, whole times exterior. So x squared equals the whole thing, which is 40, the whole segment, times the exterior, which is 10. So you're going to get x squared equals 400. And obviously x would be 20. Okay. Question 6. What's the value of x? Again, whole times exterior equals whole times exterior. So whole thing, which is 22, times the exterior part, which is 10, equals the whole thing, which is 11 plus x, times the exterior part 11. Okay, 22 times 10, 220. 11 times 11, 121. 11 times x is 11x. Put this in a calculator. I'll use this one. Okay, 220 minus 121. 220 minus 121. Yeah, 220 minus 121 divided by 11. You get 9. Okay. Okay, this one's proof. We have two tangents. They want you to prove that the tangent segments are equal. Okay. Look here. It started SB and SE are tangents. Obviously, that's given. Okay. Then they said SB squared equals SC times SI. So the tangent squared is equal to SC times SI, the whole thing. What's the reason for this? It's a theorem, right? The product of the length of the secant and its external segment. So external times the whole thing is equal to the square of the tangent. We know this. Okay. Then they said we had to choose this. Okay. SA squared equals SC times SI. Okay, for the same reason, because the length of the secant and its external segment is equal to the square of the tangent. Okay, just memorize these, I guess. And then substitution, blah, blah, blah. And then they proved SB equals SA. I don't think they'll get statements and reasons, but memorize them just in case. Okay, here they said PQ is 12. Okay, DQ is 4, EQ is 14, whatever. They want DL. They want this here. Okay, how would you do this? Okay, DL is part of a secant. They give us the exterior part, but we want the inner part. Okay, and they give us PQ, they give us the tangent. So we know tangent squared, so 12 squared equals the whole thing, x plus 4, times the exterior, which is 4. Okay, so you're going to get 144 equals 4x plus 16. 144 minus 16 is going to be 128, and divided by 4, 32. Question 9. Okay, same concept here. They give us SU is 30, SV is 10, ST is 20. Okay, find x, whole times exterior, so 20 times x equals 30 times 10. You're gonna get x equals 15. Okay, then part B. CA is 80. Okay, this whole thing is 80. CI is 10. CB equals BF. So if this is x, this is x. Okay, find the value of x. Okay, so whole times exterior, so 80 times 10, which is 800, equals whole times exterior. The whole thing is x plus x, so 2x is the whole thing. Times the exterior part, which is x, right? So times x. So 800 equals 2x squared. So 400 equals x squared. X equals 20. Okay. Question 10. Here, easy, 6 times 4 equals 8y, so 24 equals 8y, you get y equals 3. The last one's a bit tricky, okay? Same thing, don't panic if you see y minus 9. 18 times 2 is 36 equals y minus 9 times y, right? So you can 36 equals y squared minus 9y. How would you solve this? You take everything to one side, right? So y squared minus 9y minus 36 equals 0. It's a quadratic, and you simply factor. You're going to get y minus 12, which numbers multiply to get 36, but when you subtract them, you get 9. Y minus 12, y plus 3. Okay? And your two solutions will be y equals 12, y equals negative 3. If this comes in the written, you have to show that this is rejected, okay? Because the length must always be positive. So your correct answer would be y equals 12. That's it for this one. Thank you so much for watching.